Hey guys, Dr. Brown here, and tonight we're talking about revolving some shape about an axis and trying to calculate the volume. And specifically, we're going to look at two methods, the shell method and the disk method. Okay, so let's get after it. Let's assume we have some function y equals square root of x, and it's bound on y equals 0, x equals 3. Where those three curves intersect, it makes a shape. So we could think that looks something like, well, I have some function here, and I have x equals 3. This is my y-axis, my x-axis. And we're going to revolve that shape about the x-axis. So we'll start with the shell method, and again we're going to revolve that around x. Now with the shell, it says they want you to put your differential parallel to the axis you're rotating around. And their formulation then would be the volume is equal to 2 pi times the integral from c to d of, in this case, since this is dy, p of y, h of y, dy. All right, p of y is simply the distance up to this differential disk here from the axis you're rotating around. So in this case, it's just y. So p of y would equal y in this case. Now, h of y is the length of that differential, height of that box. Well, we can see that as, let me draw my little box up here, as I'm approaching x equals 3, well, that box gets really small, doesn't it? Well, since we're differentiating with respect to y, let me change this. If I square this, x equals y squared, okay? Because I need this in terms of the x value equals, it's f of y now. So 3 minus, let's say this is x, for example. 3 minus x would give me the height of that box. What is x? It's y squared. So now we have p of y equals y, h of y equals 3 minus y squared. 3 minus x, but x is y squared. So now I'm ready to perform the integral. So using the shell, we said the volume equals 2 pi c to d. Well, what is c and what is d? When x equals 3, y equals square root of 3. So we're integrating from 0 to square root of 3 of p of y, which was y, and then h of y, which is 3 minus y squared, dy. So that equals 2 pi times the integral of 0 to square root of 3. 3 times y is 3y. Y times the negative y squared is negative y cubed dy. So let's integrate that. That's 2 pi times the 3y squared over 2 minus y to the 4th over 4, and all of that from 0 to square root of 3. So let's plug our numbers in. So I have 2 pi times square root of 3 squared is 3. 3 times 3 is 9. So 9 over 2 minus square root of, so now just for the folks that we've been tutoring lately, square root of 3 times square root of 3 is 3. This is square root of 3 to the 4th power. Square root of 3 times square root of 3 is 3. 3 times 3 is 9. So I have 9 over 4 minus 0 in all of this, and all of that comes out to be 0. Okay, so let's get a common denominator here of 4. So if I multiply this by 2 over 2, gives me 18 over 4 minus 9 over 4, and all of that's multiplied times 2 pi. So that's 2 pi times 9 over 4, and that's 18 pi over 4, or 9 over 2 pi. So that's my volume. My volume equals 9 over 2 pi using the shell method. Okay? Nothing too difficult there. I'm going to write this down. Volume equals 9/2 pi with the shell. Okay? Now let's take that same function and let's look at that using the disk method. Okay, so I have that same function. Maybe I can write that a little larger. This is my x-axis, that's the y-axis. Okay, y equals square root of x. I should have done this earlier. The intersection, be careful. Some of these problems in the book we've been working through, they'll have some functions, but it's the area bound by those three curves. So where do they intersect each other, and then what's that space that's here that we're going to revolve around something? Now in this case again, we're revolving around the x-axis. Okay, using the disk method. All right. In this method, they said put the differential perpendicular to the axis you're rotating around. Okay, and the calculation then is the volume equals pi times the integral from, in this case, A to B of the major radius squared minus that'd be the outer radius minus the inner radius, in our case on x squared, dx. Well, what's the outer radius? We're rotating around, so that r of x is this distance here. Well, what is that? It's just the square root of x, right? And so it equals square root x, which is, y. It's the y value. Okay, that's part of what we need. Now then, that's the height. What's the distance it is now from, or excuse me, what is the height of this? Almost confused the two methods there, sorry. Let me draw something to better explain this. If I take that same curve, and let's say it were not on the x-axis, it's off of it. So now I have my dx drawn here, and now if I'm rotating about the x-axis, this is y, this is x, so we're rotating about x, P of x then is still the distance from the axis of rotation. It's not just the y value anymore. I'd have to account for that space. But then the inner radius is this distance here. So the distance from the axis of rotation up to the bottom of my differential rectangle. You'll notice in this function, the little r of x, the inner radius, is 0. I only have this function. So, in looking at that calculation, it's volume equals pi from A to B, so 0 to 3, we're differentiating with respect to x, 0 to 3, of r of x, which was square root of x squared minus 0 squared dx. So the square root of x squared is x. So now I'm integrating this thing, 0 to 3 of x dx. And that equals pi times x squared over 2 from 0 to 3. So 3 squared is 9, so 9 over 2 minus 0 squared over 2. It's nothing there, so 9 half pi equals my volume. You can see we ended up with the same answer in both of those, two different methods. I would encourage you to learn them both, because there's times where you may have a function that looks like, let's say I have a function that looks like that. Well, if I'm, and let's say I'm rotating that around the y-axis, or the x, let's say I'm rotating around the x-axis. According to the shell method, it would tell me I'm rotating around x, I need to put my differential here. Well, you'll notice as I'm moving up, that block doesn't change until I get up here. So I need to develop two integrals for that. But within the disk method, it says put that perpendicular to the axis you're rotating around. And now I have a function all the way from A to B. Now obviously if I'm rotating this around the y-axis, that's not the case. Okay, so learn both methods, because it may make your life easier as you work through certain problems. Okay, that's one problem. There's many more to do. So why are we doing this? Together we're trying to build a better tomorrow and do that through math. Study, guys. This is for some TSU civil engineering students. Wish you guys all the best and more videos to come. Take care. Thanks.